Welcome to the ultimate guide on number systems. Whether you're preparing for school exams or competitive tests, mastering number systems is essential. In this video, we'll break down every key concept, formula, and shortcut you need to solve problems efficiently. From the basics of classification to advanced tricks for quick calculations, you'll find everything you need right here. Let's start by understanding what a number system is and why it's so important in mathematics. Get ready to boost your confidence and accuracy with numbers. Numbers come in various types, each with its own unique properties and uses. The main categories are natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Understanding these classifications helps you choose the right approach for different problems. For example, natural numbers are used for counting, while integers include both positive and negative values. Rational numbers can be written as fractions, and irrational numbers like pi or the square root of 2 cannot. Real numbers combine both rational and irrational numbers. Natural numbers are the basic counting numbers, 1, 2, 3, and so on. They're used for counting objects and performing simple arithmetic operations. These numbers are the foundation of mathematics and are often the first type of numbers we learn as children. Natural numbers do not include zero or any negative numbers. Whenever you count items like apples or books, you're using natural numbers. They're straightforward but play a crucial role in building more complex number systems. Whole numbers expand on natural numbers by including zero. So the set becomes 0, 1, 2, 3, and so on. Zero acts as the starting point and is essential in mathematics for representing nothingness or a neutral value. Whole numbers are used in situations where having nothing is a valid answer, such as when counting the number of objects left after giving some away. This simple addition of zero makes a big difference in how we approach problems. Integers take things a step further by including both positive and negative whole numbers, as well as zero. This means the set of integers is -3, -2, -1, 0, 1, 2, 3. Integers are useful for representing situations like depths, temperatures below zero, or elevations below sea level. They allow us to perform arithmetic operations that involve both gains and losses, making them vital for real-world problem solving. Rational numbers are numbers that can be expressed as a fraction, where the denominator is not zero. Examples include 1, 2, 3, 4, -5, 7, 0.5, and 0.333. These numbers are incredibly versatile, allowing us to represent parts of a whole, recurring decimals, and more. Rational numbers are everywhere in daily life, from measuring ingredients in a recipe to dividing a bill among friends. If you can write it as PQ, it's rational. Rational numbers cannot be written as a simple fraction. Famous examples include the square root of 2, the square root of 3, pi, and Euler's number e. These numbers have non-repeating, non-terminating decimal expansions. They are crucial in advanced mathematics and appear in geometry, trigonometry, and calculus. Understanding irrational numbers helps you recognize the limits of fractions and the beauty of infinite decimal. Real numbers combine both rational and irrational numbers into one comprehensive set. This means any number you can plot on a number line is a real number. Real numbers are used in almost every area of mathematics and science, making them the most inclusive and practical set for problem solving. Whether you're dealing with fractions, decimals, or roots, you're working with real numbers. Closure property states that when you perform an operation like addition or multiplication on numbers from a set, the result will also belong to that set. For example, adding two natural numbers always gives another natural number. This property helps ensure consistency within a number system and is fundamental for building more complex mathematical rules. Commutative property tells us that the order in which you add or multiply numbers doesn't affect the result. In other words, a plus b is the same as b plus, and a times b is the same as b times. This property is especially useful for simplifying calculations and rearranging terms to make problems easier to solve. The associative property means that when adding or multiplying, the way you group the numbers doesn't change the result. For example, a plus b plus c equals a plus b plus c. This property allows you to regroup terms for easier calculations, especially when dealing with long chains of numbers. Distributive property connects multiplication and addition. It states that multiplying a number by a sum is the same as multiplying each addend separately and then adding the results. The formula is ab plus c equals ab plus ac. This property is essential for expanding expressions and simplifying equations in algebra. Every number system has identity and inverse elements. The additive identity is 0, meaning any number plus 0 stays the same. The multiplicative identity is 1, so any number times 1 remains unchanged. The additive inverse of a number is its negative, and the multiplicative inverse is 1 divided by the number except for 0. These concepts are key for solving equations and understanding symmetry in math. Divisibility rules are shortcuts that help you quickly determine if one number can be divided by another without a remainder. These rules save time and are especially useful in exams. Instead of performing full division, you can use simple checks based on the digits of a number. Let's explore the most common divisibility rules and how to apply them. Check if a number is divisible by 2, simply look at its last digit. If it's even 0, 2, 4, 6, or 8, the number is divisible by 2. For divisibility by 3, add up all the digits. If the sum is divisible by 3, so is the original number. These quick checks are perfect for mental math and save valuable time during exams. For divisibility by 4, check the last two digits of the number. If they form a number divisible by 4, the whole number is 2. For divisibility by 5, the last digit must be 0 or 5. These rules are simple but powerful, especially when dealing with large numbers. A number is divisible by 6 if it passes the tests for both 2 and 3. For divisibility by 8, look at the last 3 digits. If they form a number divisible by 8, then the entire number is divisible by 8. These combined rules help you tackle more complex divisibility problems quickly. For divisibility by 9, add all the digits of the number. If the sum is divisible by 9, so is the original number. For 11, subtract the sum of the even position digits from the sum of the odd position digits. If the result is divisible by 11, the number is 2. These rules are especially handy for checking large numbers quickly. LCM, least common multiple, and HCF, highest common factor, are fundamental concepts in number theory. LCM is the smallest number that is a multiple of 2 or more numbers, while HCF is the largest number that divides 2 or more numbers without a remainder. These concepts are crucial for solving problems involving fractions, ratios, and more. Key formula connects LCM and HCF. The product of the LCM and HCF of two numbers equals the product of the numbers themselves. This relationship is especially useful when you know some values and need to find the missing one. It's a powerful shortcut for many exam questions. In dealing with fractions, the formulas for LCM and HCF change slightly. The HCF of fractions is the HCF of the numerators divided by the LCM of the denominators. The LCM of fractions is the LCM of the numerators divided by the HCF of the denominators. These formulas help you simplify and compare fractions efficiently. Prime factorization is the process of expressing a number as a product of prime numbers. According to the fundamental theorem of arithmetic, every number has a unique prime factorization. This technique is essential for finding LCM, HCF, and simplifying complex calculations. Breaking numbers into primes makes problem solving much easier. Factor is a number that divides another number completely, leaving no remainder. A multiple is the result of multiplying a number by an integer. Understanding factors and multiples is crucial for topics like divisibility, LCM, and HCF. These concepts form the backbone of many math problems. Formula for the sum of the first n natural numbers is s equals n plus 1/2. For example, the sum of the first 10 natural numbers is 10 times 11 divided by 2 equals 55. This formula is widely used in arithmetic and helps you quickly calculate totals without adding each number individually. To find the sum of the first n even numbers, use the formula s equals n plus 1. For example, the sum of the first 5 even numbers is 5 times 6 equals 30. This shortcut is especially helpful for quickly solving sequence problems in exams. The sum of the first n odd numbers is given by s equals n2. For example, the sum of the first 7 odd numbers is 72 equals 49. This formula is a great time saver and is often used in competitive exams for quick calculations. The sum of the squares of the first n natural numbers is s equals n plus 1, 2n plus 1/6. This formula is used in advanced algebra and statistics problems. It helps you find the total of squared values without having to calculate each one individually. The sum of the cubes of the first n natural numbers is s equals n plus 1/22. Interestingly, this is the square of the sum of the first n natural numbers. This relationship is useful in algebra and helps simplify complex summation problems. Algebraic identities are formulas that help you expand and simplify expressions quickly. Memorizing these identities is crucial for rapid mental calculations and solving complex problems efficiently. Let's look at the most important ones for squares and cubes. The square of a sum is a plus b2 equals a 2 plus 2 ob plus b2. The square of a difference is a minus b2 equals a 2 minus 2 ob plus b2. These identities are used to expand expressions and simplify calculations in algebra. Remembering the signs is key to avoiding mistakes. The difference of squares identity is a 2 minus b2 equals a minus b, a plus b. This formula helps you factor expressions and solve equations quickly. It's a favorite shortcut in algebra and appears frequently in exams. Cube of a sum is a plus b3 equals a 3 plus 3 a 2b plus 3 ob 2 plus b3. The cube of a difference is a minus b3 equals a 3 minus 3 a 2b plus 3 ob 2 minus b3. These identities are vital for expanding cubic expressions and simplifying complex algebraic problems. When using algebraic identities, it's easy to make sign errors, especially with cubes and differences. Always double-check your signs to avoid mistakes in exams. Careful expansion ensures accuracy and saves time on corrections. Modulo arithmetic deals with remainders after division. The basic formula is dividend equals divisor times quotient plus remainder. The remainder must always be less than the divisor. Modulo operations are used in computer science, cryptography, and competitive exams for quick calculations. In modulo arithmetic, you can add or multiply numbers and then take the remainder. The rules are a plus b mod n equals a mod n plus b mod n mod n, and a times b mod n equals a mod n times b mod n mod n. These shortcuts make calculations faster and are widely used in programming and math contests. There are special shortcuts for finding remainders when dividing by 9, 11, x minus 1, or x plus 1. For 9, the remainder is the sum of the digits mod 9. For 11, use the alternating digit sum. These tricks help you solve remainder problems quickly without long division. Unit digit of powers often repeats in cycles. For example, the unit digit of 2 raised to any power cycles through 2, 4, 8, 6. To find the unit digit of a n, identify the base's unit digit, reduce the exponent modulo 4 and calculate accordingly. This method is a huge time saver in exams. Let's look at some common cyclicity patterns. Digits ending in 2 repeat in a cycle of 2, 4, 8, 6. Digits ending in 3 cycle through 3, 9, 7, 1. Recognizing these patterns helps you quickly find the unit digit of large powers without full calculations. The digital root is found by adding the digits of a number repeatedly until a single digit remains. The digital root equals the number mod 9 unless the result is 0, in which case the digital root is 9. This technique is useful for verifying calculations and checking divisibility by 9. Use the digital root to cross-check your answers quickly. If the digital root of your calculated answer matches the digital root of the expected result, your calculation is likely correct. This method is a handy tool for competitive exams and helps catch errors before submitting your answers. Let's quickly review the most important shortcuts. Use the LCM times HCF relationship to find missing values, digit sum for divisibility by 9 and 3, cyclicity for unit digits, and digital root for verification. Mastering these shortcuts will help you solve problems faster and more accurately. Be aware of common traps in exams. 1 is not a prime number, the remainder is always non-negative, and 0 is neither positive nor negative. Also, remember that division by 0 is undefined and perfect squares have an even number of factors. Knowing these facts helps you avoid mistakes. A decimal is terminating if its denominator has only 2's and 5's as prime factors. If there are other prime factors, the decimal is recurring. This distinction is important for understanding decimal expansions and converting between fractions and decimals. Indices or exponents follow specific laws. A m times a n equals a m plus n, a m a n equals a m minus n, a m n equals a m n, and a 0 equals 1. These rules simplify calculations involving powers and are essential for algebra and higher mathematics. Congratulations, you've now covered all the essential concepts, formulas, and shortcuts for mastering number systems. With this knowledge, you're well equipped to tackle school and competitive exam problems with confidence. Remember to practice regularly, use the shortcuts wisely, and always double-check your work. Good luck on your mathematical journey.